Good morning, Avinash. Avinash, can you hear me? Avinash? Avinash, can you hear me on the system? No, no, you have joined, but I was trying to call out your name, but you could not hear me from the system. My mic is on. Can you hear me? And have you gone live? Did you say go? Achha, this is a meeting. Okay, that's okay. So, yeah. So I think you're not being able to hear me. Check your speakers, please. Okay. So now you can hear me now. Great. Good to see you up and running. Chalo, best of luck. Call me. Just simply call me if you face any difficulty. Great. Okay, I'm leaving now.
Hi, Jeet. Hello. Jeet, am I audible? Hello. Jeet, you are not audible. Hello, Jeet.
Hello.
Yeah. Now I can.
There is some black patches. There was. Okay.
ऊपर टॉप है ना?
हाँ.
हाँ, वो टॉप है तो वो मैंने अभी हाइड नहीं किया था. वो जो एक वो होता है ना बार जो होता है वो मैंने हाइड नहीं किया था, इसलिए आ रहा होगा. वो हाइड कर दूंगा थोड़ी देर में. एंड इससे पहले मैं कुछ सुन नहीं पा रहा था.
तुम कुछ?
I was not able to hear you.
Okay. I was not connected to the audio.
Okay. Okay. तो मैं दोबारा वो कर दे रहा हूँ. अभी वो पैच नहीं आ रहा होगा कोई भी.
मिडिल में एक है.
मिडल में एक वो गायब हो जाएगा
अब
अपने आप.
चला गया. अब नहीं है.
वो प्रेजेंटेशन का वो था. जब प्रोजेक्ट किया था तो वो आता है कि एस्केप दबाइए एग्जिट करने के लिए, तो वो था. अभी कोई पैच नहीं आ रहा होगा, सब नॉर्मल दिख रहा होगा.
लेकिन ए वाला तो नहीं है आज के लिए.
बट गलत स्लाइड. हाँ, वो मैं देख रहा हूँ.
दिस वन. या
अभी ये वाला स्लाइड. ठीक.
हाँ ठीक है.
ठीक है. वीडियो भी मेरा वीडियो फीड आ रहा है ना मेरा?
हाँ ठीक है.
गुड. बिकॉज मेरे सामने केवल स्लाइड है, मेरे को कुछ नजर नहीं आ रहा. आई एम ब्लाइंड.
Good morning.
Good morning.
Good morning.
Acha, just wanted to let you know that whenever I enter, my name would show as Control Society.
Yeah.
Okay.
I noticed it earlier.
Yeah. Don't get goofed as to who the Control Society is. Because otherwise I will have to keep changing my name every time I enter anything, and which will not be possible. I'm just going to keep going in and out. Okay, great.
Yeah.
Great. Best of luck. And feel free to call me if you face any difficulty. Just call me. I will rescue you.
Yeah.
Okay.
Okay. Great. Bye.
Bye.
Hello, Vatsal.
Vatsal is here. अभी पैच आ रहा होगा, मुझे पता है. कोई नहीं. तो कैसे देखिए. अच्छा, अभी पैच आ रहा है क्या? टॉप का छोड़ दो, बॉटम में.
हाँ, वो चला गया.
चलो कोई नहीं.
हेलो.
हाँ.
अरे मैं ये बोल रहा हूँ कि
मीटिंग है ना.
Hello, Vatsal.
That is, I hope so. एक सेकंड में.
hello.
बोलिए हाँ हाँ बोलो वत्सल
Am I audible, Jeet?
हाँ हाँ you are audible
Okay.
हाय जीत।
Hello.
हाँ, अरे यार एक इशू ये है कि मैं शेयर करते वक्त आई कांट सी एनीवन एल्स।
Okay, then let me share.
हाँ, इफ यू कैन डू शेयर।
Just a minute. Yeah, I will see. Okay.
You share, it will automatically take over from me.
Yeah.
There is a pop-up.
Yeah. So we are actually switching because I'm not able to see anyone else when I'm presenting it. So Jeet will be presenting now. I'll just be.
Okay.
Now it's fine.
Good morning.
Yeah,
Good
yeah.
morning.
Good morning. All okay?
Yes.
Good. So I guess the speakers and the chair will join a little later, perhaps closer to 8:30.
Jeet, earlier it was in full screen mode, but right now it's looking like we are presenting an image.
Okay, now it's fine.
Yeah, but the size is not appropriate.
Okay.
Sorry, Devashuttam, I'm managing 2-3 things together, so I'll just come back to you.
Sure. No problem. Yeah.
Is it fine, Avinash?
Yeah, but it's not in full screen mode, right? It is not in
No.
presenting mode.
Okay, just a minute.
See, you don't have the browser?
Yeah, I have a browser. Oh, can I directly share it from browser?
Yeah. You just present it from the Google slide.
Okay.
Press F5 or click on the present button on the top.
Hello.
There is present.
Okay, present. Now it's fine, right?
Yes.
Hello, Pranav here. Can you hear me?
Yeah, I can hear you.
Yeah, sure. So,
I can't see your video. Is it intentionally off?
oh, no, okay. Sorry, it was.
Yeah, now I can see you.
Sure. Yeah. Akhil will be joining, and so just to let you know, Akhil will be the primary speaker in this case. He will deliver.
Okay.
Hello. Good morning, Dr. Lad. This is Devasattam.
Hello. Good morning.
Hi. Welcome to the session. I'm just overseeing things.
Yeah.
So please let us know in case there is any issue or anything.
Yes, sure. Let you know.
Right. And Dr. Chatterjee will also be joining, right? He is mentioned as the chair of the session.
Yes. He will also join.
Our student volunteers are here, Jit and Avinash. They will be running the show.
Right,
They will be technically managing the show.
Mhm.
In any issue, anything, they will help you.
Sure, sir. Yeah.
All right, then I guess it's all set. I'll take your leave.
Yeah.
Okay. Bye bye. All the best.
Yeah.
Hello, Avinash.
Good morning, sir.
Good morning.
Jeet,
Ajit bhi hai idhar.
Yeah, hello, sir. Good morning.
the slide is wrong. Can you correct the slide?
Okay.
Yeah, thank you.
Hi, Shovik, can you
Hi,
hear me?
Pranav.
Hi,
Yes. Hey, good morning. Good
morning.
morning, Avinash.
Good morning, sir.
Good morning, sir.
Good morning.
So I just want to let everyone know that this particular session, tutorial session, as all other tutorial sessions in this conference, will be running in a meeting mode, which means anybody can unmute themselves at any time and speak. So essentially, the speakers of the tutorial would have to kind of manage how they want to do it. Do they want to people to be able to speak up, or so you can make that clear in the beginning.
Sure, yes, that would be great. Mhm.
The other sessions will be running in a webinar mode where the audience will not have control. But since we thought the tutorial has to be more interactive, we kept it in this way.
Do we know how many people will join for this one?
Actually, we don't have a good way
Yeah.
of actually predicting because there are two tutorials in parallel.
Mhm.
So we're kind of hoping that people will split up according to their interests.
Right.
Hi, Pranav. Hello.
Hi, Avinash.
Yeah, should I call Akhil or is he joining?
Yeah, I just tried calling him. Not sure, he was not receiving. You can try once from your side.
Okay, sure. I'll do.
Good morning. Good morning, everybody. Yeah, hello. Good morning, Sanjay.
Hi.
Hey, good morning.
Good morning. Good morning, Mr. Pranay.
Morning, sir.
Hello, Shovik. Yeah, we spoke on the phone several times.
Right. Yes. Good morning. Great to see you.
Yes, great to see you. Yeah. It is beginning to feel like a conference, even though it's virtual. It's feeling like in the beginning you meet different people, talk, how are things.
Right. Yeah, that's the important part of conference.
I
It's
agree. Yes.
uh,
Yes. Okay, we have quite a few participants. Nice. Yes.
So it is 8:30. So maybe I'll just kind of make a couple of quick remarks and then hand it over to you, Dr. Chatterjee.
Sure, thanks.
So this is our first session of this 7th ICC. So let me, welcome all the participants and the organizers of this particular tutorial. So we have an exciting bunch of tutorials lined up, and I hope all the student participants will benefit from it and take advantage of that. So today we have this tutorial by MathWorks on reinforcement learning for controls and robotics applications. So this tutorial promises to be more hands-on, and I hope students will take it up. So it's a pleasure to introduce Dr. Shavik Chatterjee, who's going to be the chair for this tutorial session. So over to you, Dr. Chatterjee.
Thank you so much, sir. Good morning, everybody. Yeah, so reinforcement learning is one of those areas which is a very interesting and nice area coming up. And people specifically from the controls background, this is a great way to learn the data-based approach, which we call, but there are some differences if we compare between sort of artificial intelligence, machine learning, deep learning, conventional, and reinforcement learning. So it's a great thing if we know if we have that controls background, it helps to understand, because the workflow is sort of similar. It helps to understand the thinking part and how to frame a problem from kind of a controls problem in a reinforcement learning way. So those are great areas to learn. And those are some of the things that will be covered in this session: how you can frame a problem. We can think about how do we do start from scratch and then gradually grow to a little bit of involved problem, which, say, for example, applications in robotics or applications in some other areas. We can probably start with some game type problems and go there. That is the idea. We'll get started with all the things, and as sir mentioned, we'll have the interactions open throughout. So in terms of feel free to ask any questions at any point of time. We will take that up as we go along. So you can put it in the chat also, or you can put in unmute and speak up. So I'll introduce the speakers for this session who will mostly conduct it. I myself will also be there for any other clarifications through the question answer sessions as well. So Dr. Pranav is there in this as of now, and I'll just introduce him. So Pranav, basically all of us, me, myself, Pranav, Akhil, who are the listed here, we work in MathWorks, which is the parent company of MATLAB and Simulink. And the way our team works is we collaborate with academia in different forms. It can be research, curriculum building, curriculum development, research discussions, other sort of collaborations with academia, how to frame like industry type problems, in having any third-party industry as well. So all these different type of collaborations. And specifically for Pranav, so his technical expertise lies in the fields of vibrations and nonlinear dynamics. He has worked as a research assistant with various industries as well. And he did his PhD from IIT Bombay only in mechanical engineering. So he's, since IIT Bombay is also the host, he's kind of local in that sense. Okay. Pranav, are you there? Do you want to say something at the beginning?
Yeah, sure. Thanks, Shavik, and thank you, organizers of this conference, for inviting us for this tutorial. So yes, as Shavik mentioned, a little bit about my background. I did my master's as well as PhD from IIT Bombay from mechanical department in the domain of vibrations, basically dynamics, nonlinear dynamics, and in that as well, apart from the PhD research work that I did there, I was a part of a research assistant team which was working on development of kinematics and dynamics of machines laboratory, and also was working on some of the industry-based problems, which included some kind of robotics applications as well. For example, in solar industries, for cleaning the solar panels, creating the robots for that, and so on. So it was a sort of good learning experience in that domain as well. And now I'm working with MathWorks as a part of education team and here our primary role is to interact with academicians across India, professors, researchers, and students, and then work with them towards accelerating the pace of research and sort of improving the learning outcomes across the curriculums. Right. So yeah, that's about me. Shavik.
Thanks, Pranav. And I'll introduce Akhil once he joins. We'll get started in the meantime. Also, one thing while we are talking about ourselves, if you can mention what is your experience both with MATLAB Simulink as well as anything on the reinforcement learning. Has anybody has done any reinforcement learning before or planning to do anything of this sort? If you can put in the chat window, or if somebody wants to unmute and say, that is also fine. And also, if you can say your experience with MATLAB and Simulink, like mostly if you have used MATLAB Simulink, if so, how many years, this type of thing, so that we know where to get started from, basically. Specifically, if you have used MATLAB, not Simulink, let us know as well, so we can just maybe in a 5-10 minutes show what the Simulink platform is, because most of this reinforcement learning, you will see that the Simulink will come into the picture as well. So how about if somebody wants to maybe get started, and also we are in the morning, we are starting up, so it's good to kind of make things a little bit warm, to have a little bit of interactions for 5 minutes, and then we'll get started with the slides and some hands-on exercises, because the other part is, if you have MATLAB with you now, either it can be in the MATLAB online platform or installed, whatever. If you have it, that's great. So it will be good that if you can somehow open it somewhere. And ideally, if you have 2 monitors, that's kind of the best thing to try out things. So if anybody wants to get started, who has, I mean, your experience with MATLAB, basically, Simulink.
Yeah, maybe you can directly unmute and speak, or also you can put that in the chat.
Yeah, I'm sure all the students extensively use MATLAB and Simulink. Yeah, there we have a response there from Aniket on the chat.
Right. Thanks, Aniket. So he has used for 5-6 years numerical computation, optimization. Great. Anybody else wants to unmute and say your experience?
Yeah, hello. I'm Swiksha Jain. So I am pursuing my PhD from IIT Bombay. So my master's domain is from control. So I had used mostly MATLAB and Simulink for that purpose, and I have been using MATLAB since 4 or 5 years.
Okay, great. Thank you. Thanks.
Good morning. I'm Ravi Kiran.
Hi, Ravi Kiran.
I'm from IIT Hyderabad. I'm pursuing my PhD here. So I've been using MATLAB from 2015, and we use it for solving ODEs and we use it for optimization purposes. So it's great using MATLAB in that sense.
Awesome, great. So most of you have kind of a working knowledge how it is used. So mostly we will be, I think, skipping kind of the basics. If anybody has any questions, let us know on understanding the basics of controls and also Simulink. We can guide you to some courses as well, which you can do later on. There are lots of courses to understand MATLAB Simulink from scratch and also understand controls from scratch as well. So those are nice things which I'm pretty sure both Akhil and Pranav will show you at the end as well. At the end, I mean the second half, kind of the end of the entire tutorial. And we can mention at the beginning as well. I guess I can quickly share at this screen and share certain things while others. Let me know if the screen is visible.
Yes, sure.
Okay, Thanks.
Hi, Pranav.
Hi.
Hello.
Yes.
Yeah, I have one quick question before the presentation starts. That what should be the prerequisites for a control system student, a master's, to get into reinforcement learning or to prepare for research in reinforcement learning?
Okay. Yeah. That's a great question, actually. So, if you are familiar with the basic control system design workflows in general, uh, you should be good enough to get started with reinforcement learning as such. But what it also involves a little bit of deep learning aspect as well. Once we go into details of that, so it is okay if you are totally unaware of that part. That is still fine. We can get started with that, and then you can when you are in the journey of doing reinforcement learning, you'll be able to learn those things and then pick it up from there. But if you're familiar with that, then that sort of accelerates your workflow, right? So that is one thing. Yeah. I mean, so it's not something which is completely different aspect of doing things. So it is related to, I mean, we can use particularly reinforcement learning workflows can be used for the classical control aspects as well. So if you know the classical control workflows, then you should be good enough to start with this. Yeah.
Okay.
Shavik, if you want to add anything.
No, great. That helps. In terms of prerequisites in general, so if you want to get started later on, if you advise other students as well, so there is this page. It's called the MATLAB Academy. So here, if we go into here, there are some things. I mean, we'll show this at the end as well. But some of the things, of course, we are not talking today in terms of like the MATLAB basics and Simulink basics. These courses, these are on-ramp courses, which means kind of it starts from the basics as well. And these are all hands-on courses. It helps you to understand the basics. So the MATLAB, basically, it helps you to understand the basic syntax of MATLAB and all these things. Similarly, there is Simulink on-ramp. Now, if you go down here, you can see that there is a reinforcement learning on-ramp, which is the basics of reinforcement learning. So that's also something you can do. There are other courses, depending on your topic, you can see all those things. There is one called control design on-ramp. So that's kind of the after somebody has done MATLAB and Simulink, and if somebody wants to go for control, this is the best course to go for. It talks about control system plans, how do we linearize the PIDs stuff, how do we tune the PID and get those values of PI and D, and finally it ends with a project like control. So these courses, I mean, all of these good certificate, and it's accessible for everybody, first of all. And we are not talking about this part of the controls in this event, in this workshop. So these are some of the things which you can do later on at your end. The reinforcement learning, which after hours workshop today, you can try to do it later on. That will also help, because that's a great point to start things and sort of reinforce the idea of reinforcement learning into our head, if we say in that way. So these are all nice courses which you can go through later on. Right, so these are helpful. Okay.
Thank you, sir.
Okay. Any other questions before we sort of get started with this? Okay. Oh, Akhil is also here, so I'll introduce the other speaker for this event, and while he gets started with the slides as well. So these are some of the prerequisites. And again, if while we go along, if you have any questions and all, please let us know at any point of time. We'll be happy to take that up. So I'll introduce Akhil as well. Akhil has joined. Akhil also is in our group, same as Pranav and me. So we work with the academic team. His experience, he's chemical engineering by training, and Pranav and I are mechanical engineering by training, because the word I'm using by training is because after that we all switch to different domains. Everything is interdisciplinary, and we all learn from each other. And reinforcement learning is something which again gets useful in all other different domains as well. And you can see how things can get pretty interesting and fascinating once we use this in conventional topics like controls. So Akhil has a master's degree from IIT Madras, and he's an expert in the area of reinforcement learning. He can talk to about all these things in different domains as well. Okay, so since they have joined, maybe I'll stop sharing the screen. And so this is there. You can go to this later on, all these courses. And in terms of the exact slides and things, feel free to, I'll stop sharing and Akhil can share as well. The other thing is, again, if you want to do some of these things, please, we don't know, I mean, many of you have shared how you have used MATLAB and Simulink. Many of you have lots of experience in different forms of MATLAB Simulink. As of now, if you have access to MATLAB, I'd suggest you can keep it open, and then once you go along, you can try out some of the things which we'll be talking about. Okay, thanks. Over to you, Akhil and Pranav.
Hi, Shavik. Good morning. Hi, everyone. Good morning. Thank you. Do let me know once you're able to see my screen. Perfect. Is it visible now?
Yep.
Yes.
Great. Thank you. I hope I'm audible.
Yes, perfectly audible. Thank you.
Right. Good morning, everyone. Apologies for the slight delay. I was having some technical issues to join up. I hope you are all doing good. And thank you so much, Shavik, for walking through the different aspects of self-paced training, etc. And thank you. I think I have seen a couple of things being shared in the chat window by Pranav. Thank you again. So without much delay, let me begin. So Shavik has kindly introduced myself. So I'm Akhil Gopinath. I work with the education team at MathWorks. So today we'll be trying to work with reinforcement learning. We'll try to understand what reinforcement learning is, how it is useful for us in terms of controls, specifically in terms of robotics, because it's one of the more intuitive and also complicated examples that we can work with, right? At any point of time, if there are any queries, any questions, or anything that you believe is not clear, please let me know. The whole idea behind this particular interaction is to ensure that we are all in a better position when it comes to reinforcement learning. If you have not heard of it before, or if we have worked with reinforcement learning before, we should be able to implement it in a little bit more quicker, faster, and effective way for our problem statements. I hope that makes sense to everyone. And let's begin then. So there are many real world problems that we come across quite often than not. Like, if we want our cars to be autonomous, we want it to be navigating through the traffic, keeping us safe, taking us to the destination, or we want our, like AIs to start playing games with us in a very intelligent way, how a human being would play with us, right? So that we don't have to wait out for people to join up and play. Or we need, the prosthetics for people who are wearing prosthetics. It should be a little bit more responsive to what their brain is thinking and work accordingly, right? Because now it may feel like an additional, not a part of their body thing, right? But if it's moving and working and feeling like the way it is, the real one would have been, it would be a little bit more comfortable for them to work with it, right? Or like, as I said before, like a scenario where the car is trying to navigate, right? If we are able to actually do that, it'd be great. Or a robot working on a straight line, right? Now, I want everyone to think about one small thing. What do you think is the difference between, a machine in these kind of situations and a machine that we have usually or typically seen in our daily life, right? So the hint word is interaction. If you notice in each of these, examples or each of these problems, the requirement is the machine need to interact with the environment, right, to make certain decisions. In this case, the car has to interact with the cars and the road. In this case, prosthetic has to interact with the user and the path and the way that it is moving ahead. In this, the robot has to interact with the path it has, right, etc. Now let's figure out how do we solve these problems, or what is one of the way we can solve this problem. Okay. So for that, we'll be taking this example throughout, that is to make our own walking robot. We'll try to see if we can have the simple biped robot, which has, 2 hip joints, 2 knee joints, 2 ankle joints, and try to see if we can make it work. Please do not worry if you are not comfortable or you do not understand the equations of robotics. That's not what we require. What we'll be focusing on is how we can actually develop some certain control algorithms for this particular robot so as to make it walk on 2 legs. Okay, and this particular method of implementation can be extrapolated to any other problem set that you may be having. Okay, right. So our ultimate objective is that our robot, which looks like this, should be walking like that. Okay, great. So traditionally, I'm pretty sure everyone is aware of this particular workflow by which we can actually make the robot walk, which involves state estimation, then trajectory generation, then ensuring that we are able to put certain control in there to ensure that the trajectory that we have mapped out is actually being taken care of. Now, this particular process is powerful. It has been done. It has been done, and it's being done, and robust too. But the problem lies the fact that when you have multiple such possible states that you have to work with, right? In this particular robot, it is little less. But considering that you may be having complicated robots with complicated relations and many more states or joints to control, then this thing becomes very complicated and very much computationally inefficient, right? Now, how do you actually get ahead with this? What if I tell you that there is a kind of black box controller who can actually do an end-to-end, get an end-to-end solution to this particular problem, right? And that black box controller for us would be the reinforcement learning algorithms. Okay, so let's try to figure out what that is. Now let's get into the world of reinforcement learning, try to figure out what it is. Meanwhile, if you have any questions or queries or anything that you believe you need me to talk about, please do put it in the chat window, and Pranav will let me know what's happening, when it's happening, and etc., so that we can take it up as and when it comes. Okay, great. So what is reinforcement learning? So let's get started with the very basic fundamental understanding of what this is, and then we'll get into more application perspective. Okay, so reinforcement learning, I like to take an example of a lady trying to train a puppy to fetch a stick, because that gives a very intuitive way of understanding what this might be, right? The way she does is she throws the stick and says fetch. The puppy tries to see, observe what the lady is trying to do, then try to think what it should do as an action. It can do anything. It can just sit there, stare at the lady. It can run away. It can run towards the stick. It can go fetch the stick and just run around and round and round. It can be anything, right? So based on certain logic, it actually does some action. It takes some action. It says, okay, this is what I'm going to do. Now this action can give two things, right? Either it can be something which is good or it can be bad, right? If it is the correct action that the lady wanted, that is, the dog is going and fetching that stick and coming back, right? In that case, the lady is going to give the dog or puppy a treat. And using that treat, the puppy is going to learn every time it is going to get the treat that, hey, doing this particular action is getting me a treat. Now let's put that in machine perspective, right? So reinforcement learning is a kind of way that the machine will learn, or an agent will learn, by doing certain trial and errors, right? And these trial and errors are nothing but interaction with an environment. Okay. Now we'll define these small words also as we move ahead so that we are all on the same page. So this is a generic definition of what reinforcement learning is. Now, before we go into any further detail, let me kind of differentiate between different types of way, the machine learn. So we are very much familiar with unsupervised learning and supervised learning. Reinforcement learning is the third vertical that's out there. Okay, unsupervised learning, as we all know, it's the data is being given to the machine, and the data contains only the inputs. We do not contain the labels that it corresponds to, and the machine is trying to find commonalities or patterns in the data, and whether it can cluster it according to its that pattern or etc. So that kind of a technique is unsupervised learning, wherein the machine is aware of the data, but it is not aware of what the data corresponds to, right? On the contrary, supervised learning is when the machine is aware of the data which is being used to train, and also it is aware of what the data correspond to, right? So there is a labeled data in this case. So in the context given below, you can see that if there is a scenario wherein I have to segment between roads, trees, and other entities in the image, which I already know, and I have data which already I have highlighted and labeled everything, then I'm trying to train my system using that. So that becomes supervised learning. The third type of learning, which is reinforcement learning, let's take a different scenario. For example, there is a smart car, right? And the computer of the smart car wants to navigate through this traffic, and this is one of the scenes of the traffic, right? So what it will do is, at this particular time t is equal to 0, it's trying to look at what's happening. Then for the next time step, it's trying to figure out what next action to take. Correct? So basically what is happening is, at every step it's trying to, or it is interacting with the environment, understanding the different variables out there that it is observing, or observing various different variables out there, and trying to figure out, okay, if this is what the situation is right now, this is the action that I have to take, right? Because of which I will be given a very good reward, and I shall be doing a good job of achieving my objective. So that's how the reinforcement learning will teach the machine. Okay. Now the question will come up, where does deep learning come into picture? So deep learning is actually encompassing all these three sub-vertical. Deep learning can actually be unsupervised, supervised, or reinforcement, can be a part of all these three. In reinforcement learning, particularly when there are complex problems, deep learning comes very handy, because we typically use deep neural networks to solve these problems. We'll take a deeper look at how this happens as we go into this area, but just to give you a perspective of where all of the different things fit. Okay, great. So before I talk about the training work, Shranab, if there are any questions, do let me know in the chat window.
Yeah, sure. Till now, no questions.
Okay.
But yeah, people
Great.
can feel free to post them in the chat, or also unmute and ask. Yeah.
Thank you so much. So let's actually get into a little bit more detailed version of how reinforcement learning training works, right? So we have understood one thing by now, that reinforcement learning works through trial and error, right? We have seen that it interacts with the environment in a trial and error fashion and try to figure out how to do the best thing, right? And we took the analogy with the puppy training. So just to put certain words in picture, the puppy in our case is equivalent to what we call as an agent in reinforcement learning. Okay, it is the entity which is trying to learn certain required action, okay, interactively. Now there are observations. This is self-explanatory, I guess, observations. Then there is environment. So the observations are being made from of the environment, right? And the agent is actually making these observations from the environment. And environment can be, in this particular case of pet analogy, it is the the lady, the words she's speaking, the actions she is doing, and where she is exactly. So this kind of things are observations of environment, and on those the observations are being made by the puppy. Then there are actions, right? Every observation will lead to certain action to be taken by the agent, right? So that action is something that the environment that would be applied to the environment. And when we apply that action to the environment or perform those actions on the environment, what happens is the environment will actually return a reward. Sorry, before that, the observation and actions are mapped together with policy. That means in puppy's case, the puppy's brain will be taking certain, actions based on the observation. So the brain is equivalent to policy for our case in this. It's not exactly that, but let's for simplicity assume that policy is like the puppy's brain. Okay. And the environment is going to reward or send a reward to the agent based on whatever action it took, right? Whatever action it took and whatever logic you have put for reward, it will give the reward to the agent. Now comes the most important and interesting portion. For puppy, the learning process happens by, in a biological manner, right? The brain makes new connections, create new neural connections, etc. in the brain. But how do we actually train our machine to do that, right? That's where reinforcement learning will come into picture. What happens is the reinforcement learning algorithm will try to understand what is the current scenario, what is the reward or how good the reward is. And based on that, it updates the policy and try to figure out what can be a good policy which can map the observations with the actions, right? That's the whole idea. Now we'll take a deeper dive into each of these verticals as we go ahead so that we are in a better position when we are implementing that for our biped robot. Okay. So if there are any questions, again, please put it in the chat window. So let's put these words that we have just learned into a engineering example. Okay, the self-driving car that we have been talking about. The agent for a self-driving car would be the vehicle's computer, the controller or microprocessor, which is in the heart of the self-driving car. Then the observations would be the sensor measurements, right? The sensor can be cameras, it can be lidars, it can be ultrasonic sensors, etc. So which are the observations which the agent is making, which is the vehicle's computer. And these sensor measurements actually represent the environment conditions, the environment being the road, the position of the vehicle, these are kind of which encompasses the environment. And finally, the policy will take certain actions like, steering, braking, accelerating, etc. I'm so sorry. Is there any question? Apologies, I was not able to hear you properly. Could you please repeat your question?
No, I think there was some noise.
Oh, okay. Thank you. And the way that the computer would be able to take these actions or what to do is based on the policy. Okay. And last but not the least, in order to ensure that the policy is being updated, we need to figure out a reward for it, right? The reward for us in this case is based on what we wanted to achieve. That is to ensure that it takes less lap time, or it is highly fuel efficient. So these can be kind of like objectives of this particular agent. And last but not the least, our reinforcement learning, which would keep on iterating over the different trials and ensure that the policy is being updated in the right direction. Okay, I hope this gives clarity to everyone with regards to what different entities would be. So now, if you have any problem statement at mind that you would want to share, wherein you believe you can see RL in your own domain, do drop your ideas in the chat window, because then we'll take a 5 minutes break after this so that we can actually take a look at how these different workflows that you have put up can be put in terms of reinforcement learning. Okay, great. So now the thing is, we cannot always keep on having this policy being trained, right? Or the reinforcement learning algorithms update the policy forever and after, because it will involve a lot of computation, right? So we need to decide on something known as trained, right? We have to finally figure out, okay, now my policy is taking these observations and actions in repeated fashion with good reward, cumulative rewards coming into picture. Now I need my policy, reinforcement learning algorithm out of the picture. I don't want to update my policy anymore because it is already good. So that good is where you have to figure out, what do you consider as a trained policy? Once you have decided on what is the trained policy, then the beauty is you only need the policy to work with the reinforcement learning now, because your policy is now a very good mapping between observations and what actions to take in order to get the best reward, right? So you no longer need to have any reward coming in from the environment or any updation that is going to happen. So these kind of things are not required. You only need the policy to be there with the vehicle in case of smart car, so that it can do all this variables. Now, but let me highlight the word. It is only after you consider this to be trained. It is very subjective to the people or to the application. To give you a very 50,000 mile high example on what this might be. For example, if you have a Tesla car, or let's say you are creating one of your cars. Okay, let's say me or Pranav and I created one automated, let's say three-wheeler or an auto rickshaw. Let's assume an auto rickshaw, right? We have created a self-driving auto rickshaw, and at that time what we did is we trained that auto rickshaw to work with the let's say Mumbai traffic system, right? We put the system with respect to Mumbai traffic scenario. We trained it. Now it is, according to us, able to navigate through the Mumbai traffic, right? And we were able to actually put it there, and it was working beautiful. Now people got excited from different parts of India, let's say Bangalore, right? Now people got excited and they said, hey, I want this particular thing in my state. So people, people took that trained, auto, put that in Bangalore environment. Now the thing is, my policy, I have considered it to be trained for a particular type of traffic scenario which I have been observing in Mumbai. Assuming that the traffic scenarios in Mumbai and Bangalore are entirely different in terms of the kind of traffic we observe there, the way the traffic works, the traffic kind of roads that we have, whether the GPS signals and everything is quite nice or not, exactly, right? So these are kind of different things that we have to account for, which the policy have never ever interacted during its training process. You understand? It's like picking up a baby from its natural environment, which is a home environment, and expecting it to work efficiently in a very, very new environment, maybe in a school, day one, right? The baby has never visited school before. It has never encountered what different things are kept in front of it or anything. So it is clueless, right? In this case, it may not be clueless. There might be certain things it can do, but it will not be able to effectively work the way it was working in the environment that it was trained, right? So I hope that gives you an idea of why this policy is very important and why this definition of trained is very subjective, and you have to understand and identify what is the requirement, and based on that you have to create a create an important lining or definition of what trained mean. Okay, that's the reason why we spent so much time focusing on this.
Okay, there is one question in the chat. So the
Yes.
Question is whether the policy training will be done offline or online. So that's the question. I mean, whether the agent will learn when it is actually doing things, or it would be just will be trained and then I mean, whether it is done in the software or hardware or those things.
I'm sorry, these are two different questions, or is it the same question?
Same question. The question actually is whether the policy training is done offline or online.
Right. So actually, there are multiple ways by which we can actually do this. So I will park that question to the point where we will be talking about policies, agents in specific, because it also has to, we also have to bring in the reinforcement learning algorithm to actually tell you whether it is off policy, on policy, etc., right? Or online, offline, whether it is soft or hard, whether it is model based or non-model based, etc. So there are many other diversities that also we have to first come to before I can answer that question. Does it make sense? So that everybody is on the same page when it comes to understanding these questions. I hope that makes sense.
Yeah, you can go ahead.
Great.
Yeah.
Thank you so much for the question. That is an interesting question that we'll be taking up. Okay. Great. So for this particular self-driving car, by definition, we can say a policy is trained if we have, if we have optimized that lap time and we have getting the, lap time to be quite fast and the fuel efficiency is quite nice. Okay. And this quite nice is something which is qualitative when we speak of, but in real world, you need to quantify. Okay. Great. Now with that, let's draw some parallels with control systems, because after all, we are looking at reinforcement learning to kind of, shift our focus from the traditional control, controllers and control systems to something which is more end-to-end and, robust. Now let's draw some parallels to it so that we are able to, kind of figure out where our RL agent and policy and other things would come and fit into. So as it comes to it, there are many parallels we can actually build up. So I think most of this would be intuitive, so I'm not going to, ask them as questions, but let's see. So we have controllers, which you would have guessed is equivalent to what the policy would do, right? We have plant, which is equivalent, or environment, which is equivalent to the plant model, right? There are measurements, which is equivalent to observation. There is manipulated variable, which is nothing but the action in terms of reinforcement learning. There is error or cost, which is equivalent to the reward function, right? And last but not the least, we have adaptation mechanism to tune controllers parameter, right? Whereas for policy, we have the RL algorithm, which is trying to update the policy, right? I hope this gives you a clear idea of what different entities would be related to what different entities in reinforcement learning, right? Great. So now let's move ahead with this information. Why this is important? Because if there is a traditional controller out there and you want to try it out with, let's say reinforcement learning, there requires, I would say, minimal modification in terms of the flow. There requires modification, but it is lesser than what we expected to. We don't have to, reinvent the entire system in order to actually work with reinforcement learning. And we'll take a look at that too. Okay. Great. So for the first half today, we'll be talking about qualitatively implementing a reinforcement learning algorithm. And this would be based on each of our intuition for helping this red dot navigate in this grid world. You can see this is a world which is made of grid, right? The red circle or red dot, whichever you want to consider this, is we are trying to ensure that it is on its own able to navigate this grid world and reach this blue square in the shortest possible path, right? That's our objective. Is that clear to everyone? So we will be qualitatively, we would be discussing all of you. I request you to participate in this. We would be working it out in a thoughtful fashion, how we can proceed with this and how we can actually make this red circle navigate to the blue square.
Before that, Akhil, one question in the chat from Ajul Dinesh. So there seems to be a little bit confusion about whether plant is analogous to agent or environment.
Okay, let me actually take a step back here. Right, whether the plant is Analogous agent. Okay.
Yeah.
Okay. Let's think about what happens to the plant. So to a plant, we put some manipulated variable and we measure what is the response. Correct? Similarly, in environment, we perform certain actions on it and we observe what happens based on that action. Right? Whereas for agent tries to understand what observations have been made and how the action need to be changed so that the reward is better. In plant, the measurement is kind of compared to get the error, and the controller tries to figure out, okay, this was what I did, this is what the error is, and I need to reduce this. So I need to take certain actions based on that, which is manipulated variable. Is that clear now? How plant is equivalent to environment and agent is equivalent to the controller, or policy is equivalent to the controller?
Yeah. Yes.
Okay. Please feel free to ask any question. Please do not hesitate, because we are here to learn, right? And it's more than happy to see the questions come up. Great. So I hope this problem is clear to everyone, and the objective of this problem is also clear, right? Now you will have to work with me on this, everyone. So please do not hesitate at any point of time. If you have any questions, doubts, or anything that you want to share, please feel free to, because that's what we are here to do, right? Great. Now, before this, let me introduce you to a reinforcement learning workflow. So this particular workflow is quite generic, and this is applicable to any of reinforcement learning problems that you will face. So the first thing that is there in this workflow is the environment itself. Normally, we typically we start with environment, whether we have an environment in the first place, whether we have access to it or not. But we need certain environment, right? We need to make some observations, and we need to apply some actions and figure out what the reward is. Now, second is, while talking about reward, we have to figure out what is the reward. And we'll take a deeper dive into this and why I'm emphasizing this as a very important vertical out here. Okay. Then we have to decide on what kind of a policy that you want to put up, right? And we'll also talk about what different types of policies are there, because we have to decide on what logic should be taken to, decide on what action to take. And we need to set up an agent which will be updating our policy, right? Which would be keep ensuring that the policy is always being in the best possible scenario. Then once we have decided on all these moving parts, then we have to start training. We have to start training our policy, or rather our agent, in order to ensure that the policy is becoming better and better and better, and we are getting better and better and better rewards, right? But that is not the end point. Once you have gotten your policy, which you consider to be trained, that should not be only put up in terms of your system that, hey, I have done this, right? It is something meant for something real. It's trying to solve a real world problem. So you have to deploy it to that real world, right? So that becomes a very, very important vertical that we quite often miss out on. But that is also a real portion, right? And we'll talk a little bit on deployment today, because our major chunk of time would be spent in understanding what the reinforcement learning is and how to implement that. Okay. Great. So our problem, let's revisit this. We want to ensure our red circle is going to the blue square in the shortest possible path, right? Now work with me on this. So what is the environment out here? I hope I'm audible, and in this case, I'm pretty sure we all will agree that the environment is nothing but the 5x5 grid world, right? That is our environment. What is the agent? So we define that agent is the entity which is trying to learn to do certain actions, correct? By interacting with the environment in a trial and error fashion. In this particular case, what is the entity trying to learn? Or which is the entity? This blue, this red, circle is actually trying to navigate through this particular grid world and trying to reach this particular blue square, right? So this is analogous to our agent, which is trying to learn, correct? Now, we specified that we need rewards in order for this to, kind of learn, right? Agent requires a reward to be given by the environment so that it is able to learn whether it is the right action to take or not, right? So what do you think in this particular case, when we have to navigate to the blue square, what do you think would be the reward? Can you take a guess and drop it in the chat window? You even if it is not a quantity, you can just let me know what kind of a reward do you believe, or let me make it even better, right? What can be the reward? Yeah, please go ahead.
The norm distance between the red circle and the blue circle, and
okay.
If the in ith step, if the distance is 1 and it increases in the I+1th step, then the reward is negative, and positive if it decreases, like that.
Okay. So what do you think I should give it as a reward if the distance is, reducing, and if it is increasing?
If it is reducing, the reward should be positive. That yes, we are moving
Okay,
close.
let's say +1. Let's say
Yeah.
plus. Okay.
Yeah.
And so when the distance is reducing, it should be -1, right?
No, the opposite.
Opposite. Sorry. Yeah.
Yeah.
When it's the opposite, it's -1. When it's increasing, it should be -1, which is negative reward. When it is reducing, it should be +1.
Yes.
When it is same,
it is 0.
It is 0. Okay. Cool.
Like we do see in competitive learning.
Okay. Now the problem is, for that to come into picture, right, we have to define one more thing. How or what actions can this particular red circle take, right? It can, in any context, you can think of, it can go up, it can go down, it can go right, it can go left, it can go diagonals, right, diagonally. But for our case and purposes, what we are going to say is it's going to go up, down, left, right, right? Now, any other ideas with regards to reward? That's a fantastic idea. Thank you so much for sharing. Any other ideas, anyone? Or everyone agrees to the similar thought?
Maybe we look at the blocks that are required to reach the blue dot, something like a network.
Okay, that's pretty interesting. Can you please elaborate on that?
So, for instance, I would be looking at the shortest path in terms of grids to reach the blue dot. So, it would not include the obstacle, that is the black block.
Okay.
So, something like that. So, if it is, if that number is small, then the reward would be high.
Okay.
And if the number is higher, then the reward would be, it would not be rewarding, it would be opposite, like it would subtract maybe.
Okay. So basically the number of blocks we are accumulating or we are moving to, right?
Yeah.
Okay. Yes, we have to consider the obstacle also. That's a great observation. Thank you. See, we are reinforcing our understanding of reinforcement learning right now. So we all get the sense, right? Now let's define what rewards are for us and them. Great. Any other ideas towards rewards? We have got 2 fantastic ideas as of right now. 3, I think. One is their number of steps to the blue square. Okay, great. That's a great and simple reward setup, Anuj. Can you please elaborate on how would you put a reward for this? Like every time I move, I would be rewarded or something, right?
Like if you take an action, if that is reducing the number of steps to the blue square, it's a positive reward.
Okay. Right. So we have to first of all, understand that whether there is a blue square or not. The system should be aware of that, right? So we are assuming that we know what is the location of blue square and the system is aware of what is the location of the blue square, right? For all means and purposes, let me put into a reality. Let's assume we have been put into a maze and we have to come out. Maze, right? And we have to come out. We, ideally speaking, we do not know where the exit is, right? We do not know where our ultimate point is. We only take certain, decisions. We take go up, go down, go left, go right. we take these decisions trying and hoping that we will ultimately be free, right? Or we will ultimately find the exit. So if your reward is determined based on what is the location of the blue square, right? That would actually constrain your problem a lot, right? And that may not be also technically correct in speaking with respect to the information that the machine already have, right? So you get the dilemma of putting any reward which is based on what is the location of the blue square, right? Does that make sense? So what we need is something which is agnostic of the blue square, but at the same time, you know, it should be giving a better reward when it actually reaches the blue square. So let me give you an idea. You know, this is something that I am developing from what Anuj mentioned, the number of steps taken, right? So we all agree that we want to reduce the number of steps taken. That is what we have all agreed on, right? What if for every step taken we are rewarding, right? For every step that the agent takes, let's put some reward, right? And let's assume that whenever it takes a step which will lead to blue square, we will reward it, let's say some big value, right? Let's say plus 100 or something. How does that sound? Are you with me in this?
So
Yeah,
I had a
go ahead.
question about it. So in a way, we are exploring the whole grid. So are we keeping a history of the previous steps so that when we actually reach the blue square, we can create a backward map?
Well, that's something that you will have to tell me, right? So this is something that we are going to build together. So first step, let's figure out you know, how we are going to reward the system. Then later on, when the policy comes, we will work on this also. Okay, Anuj?
Okay, sounds good.
Yeah, we'll try to figure out what might be the logical way of doing this. Okay. So everyone, are you okay with me rewarding the system at every step and giving a plus 10 or 100 or whatever it is, a great bigger reward when it is able to take a step to the blue square? No matter where it is, then it will be able to get the plus 10, right? No matter where the blue square is. Do you think that's okay?
Yes, in the case of variance, like if the variance increases, then it is a squaring, and it goes means penalize more if it is going in the wrong way, and reward
Perfect.
more. Yeah, like that.
Right. Thank you so much. That's a fantastic thing. So what I can take from it is, whenever there is a step which is being taken, it is not a good thing for us, because what we want is it should be taking the minimum amount of step. Ideally speaking, what we are hoping is if it takes the first step, it should be ending out in the blue square somehow, right? That's the best scenario. But the point is that's not the case, right? So for us, every step that the red circle takes is not a desired quality. So what we can do is we can put a negative reward for it, right? So what if I say for every step that is being taken on the gray square, right? This gray squares, I'm going to reward it -1. So if it goes from here to here, -1. If it goes from here to here, -1. If it goes from here to here, -1, right? So in that way, it is getting negative rewards. Negative rewards are not good, because our objective is to basically improve the rewards, right? Get a good total reward. Great. So for our understanding, so I have put -1 for every step that we take, plus 10 for the step which will lead to the blue square, and right. So we have a question in the chat window. When we reward for every step, are we not increasing the computation time? Thanks. Well, technically speaking, yes. But this is also, this is also important. We have to understand whether the step that we have taken is actually right or wrong, right? Whether the step we have taken is in the right direction or not. So yes, this is computationally little expensive. But in this particular case, the expense is not, observable. It's very, very less, because it's a very trivial problem that we are working with, right? And the reward is kind of stationary for us. It's not a functional evaluation or something of that sort, right? So that's a good question, Shrikant. Thank you so much. Great. So now you would have observed two squares being left like this. So that's because I want to bring a twist to the problem. Okay. Instead of having -1 only, what happens is if the red circle reaches this particular square, what we are intending to do is we are saying, okay, this is a magical square. The red circle is going to move from this particular square to this particular square. You know, magically it will be teleported kind of from this to this. And along with the -1, it would be, putting up, or it would be given for navigating to this particular gray square. It will be getting a +5 reward for teleporting from here to here. Right? Is this clear? I hope this is. If not, do let me know.
Can you please repeat that? Because, like, do you mean that skipping the obstacle, or is it those two?
Skipping the yes, exactly.
Okay.
So the whole idea is if the red circle reaches this particular square, we are saying this is a magic square, which will help the red circle to, jump over this obstacle or teleport over this obstacle and reach this particular square, right?
Yeah. So is it only like, is it just an example that you're giving, or is there any other block that we could? So like, what is there some justification or just an example for?
No. This is just an example.
Okay.
Because we are the creators of this environment, right? We are creating this environment and we are creating the, scenario that we want our red circle to work with. So we have the flexibility on choosing what all different, activities that can happen in the environment. So for this particular example, I'm saying, okay, I have to create a magic square just because I want to, maybe make things a little bit more different and not so linear, right? Because if I put -1 for everything, we can see exactly what the solution might be. But the moment I put, a different square out here, which is able to, put our, red circle from here to here, things become very different because now we are getting a +5 reward from here. Right now, things are not that intuitive, if you notice. So this is just for an example purpose. You can choose what all different things that you want to put up in the environment. That's the beauty. See, you are basically the creators of this environment, and you have the flexibility on deciding what all different things can happen in the environment. Okay, great. And based on what all things can happen in the environment, you have to decide on the rewards. So we have decided this is the reward setting for our problem. Is this clear to everyone? If there are any questions, please feel free to ask. Okay.
Just a question here.
Yes, Amish.
So does the agent know before taking an action what the reward will be, or it only knows after like moving the step, it knows what reward it got?
That's a very good question, and that was the final point of this particular presentation. Oh, sorry, this particular slide. Yes, the agent is not aware of any reward that it can get. It only gets the information of the reward when an action is taken. Before that, it does not know what the reward is. And it is trying to guess or estimate what the reward might be. Yeah, please go ahead.
Another question, like if the reward becomes too negative, does the activity of the agent reduce, or is it independent of the reward?
It depends on what we want to, put as the activity that the agent can perform, or what we put as the, exploration limit. Like if we say, okay, if you have accumulated this much negative reward, please stop.
Okay.
Right? That means you are not at all in the right direction. Please stop. So this is something, this is the logic that we will have to decide on. You understand? So we will be taking these all nitty-gritty understanding. Thank you so much. These are the questions that are pertinent, right? And this is great thought process there. Thank you. So just to formally, define, we will have to figure out how to let the system know where we are right now. Correct? So we have to tell that, okay, I'm in this currently in this particular state. In this particular case, this can be, the coordinates of the square where we are, right? It can be row, comma, column, or column, comma, row, whichever you're comfortable with, right? So we put up a coordinate system. So in this case, I'm going to say we are starting from 1, 4. So we are putting column first and row second. Okay, that's the coordinate system that I am assuming because of the flexibility that we have. Okay. So right now we are starting from 1,4. Great. And we have to reach 5, 5,1. Okay, great. All well and good till now, I hope. And the actions that we can take is either we can go up, we can go down, we can go right, we can go left. Great. And we all agree with the information that we have put up over here too, right? Great. Now, one final word, which Anuj have already mentioned, and that is the red circle does not know what the possible reward values are. It does not know. It's just there, because if it knew what the reward values are, it can immediately compute what to do, no matter where it is, right? That's the whole idea. If it knows exactly what the reward is already, then it can immediately compute what is going to happen, right? In this particular case, because this is a very, very small world. So let's see, what are we talking about when we do not know the reward, right? How it should be working on. So when it does not know any reward or what the reward is for any block, at every square, it can take 4 possible actions, right? It can take 4 possible actions. And based on what action it takes, it will be made aware of whether the action was good or not. Correct? So now let's assume that because reinforcement learning is all based on trial and error, we were trying out something. Okay. So before that, let me introduce you to a word, episode. Okay. So episode is basically a set of these, actions and observations. So till we are reaching the end point or reaching a termination condition, okay, that we call as an episode. So the whole idea is, in this particular case, what we are trying to say is, we will try to look at this, we will try to observe, or we will try to work it out or simulate this particular process until and unless it reaches this particular blue square. Once it reaches the blue square, we are going to terminate it. Okay. And that particular entire process of navigating from here to this particular point would be called as an, as an episode for us. Okay. The termination condition, as there was a question, it is, for me, I have chosen that once it reaches the blue square, the process will terminate, right? There can be another one. You can say if the negative reward is more than 30, let us assume, right? Then terminate. That can also be a termination criteria, correct? Because it is possible that it is not able to try, find a proper solution. It may be like going rounds and rounds and rounds out here, right? And it may accumulate negative errors very much. So at that particular point of time, you do not want this to go on forever, right? Because it is not computationally efficient and also time consuming. So you want to terminate it. So you have to put one more termination condition, which is if the cumulative reward is, it's more in negative direction, then please stop. Right? Great. Are we all in the same page when it comes to episode? I hope we are. If there are any questions, again, please feel free to drop it in the chat window. So the whole idea now is, we have to take certain steps. Every episode, we will be performing, certain number of steps, and we'll be observing what actions we are taking. We will be observing what rewards we are getting, and trying to, better our agent to make these decisions more effectively in the future trials and errors, right? So during one such episode, this happened. Okay, in one such episode, this happened, in which the agent was trying to navigate, and this was the direction it took. It first took a right action, it got some reward. It took a right action, it got some reward. It took an up action, it got some reward, and so on and so forth. And luckily, it so happened that it was able to stumble upon this particular square where it got a +5 reward, and it was able to stumble upon this particular square 2, which gave it +10 reward, right? Now the beauty is, our reinforcement learning algorithm, or the agent in its entirety, remembers exactly what actions led to these 2 rewards. Taking a down action rewarded it. Taking a right action rewarded it. Now the agent is learning. Okay, it seems these two steps actually gave me a very good reward. I have to keep this in mind. These two steps seems to be favorable for me. Okay. Now, continuing our trial and error and the learning process, ultimately, our agent would be able to find the best possible path, right? It's able to find the best possible path with respect to, the current state it is in. And we find that this is the best possible path, right? Now, the thing is this the best possible path? Let's first discuss a little bit more on this, and then we'll figure out how it is being done. Okay. So we are assuming that our agent, the red circle, has learned how to navigate from this particular point to get the best possible reward to reach this particular square with the best possible reward. It has learned what actions needed to be taken, right? That's what we are assuming. Can you tell me what is the total reward that you can get in this particular scenario? Can you compute it with me? Okay, we have plus 12 in the chat already before even asking. Great. Right. So it would be like what? -1, -2, -3, +5, -2, and that, sorry, +2. That would be +1, and that would be 11. Total is 11, right? 11 or 12, considering whether you give a -1 here or not. So depending on what you have decided, whether you will give a -1 first for jumping to the square and then give a +5, your reward would be either. I'm sorry. I'm sorry. Great observation. Yes, if the working area is big, then it would be complex, right? Let's try to see if it is, right? Intuitively speaking, yes, it would be complicated if the grid world is bigger, right? If it's a grid of 10 by 10, the complexity increases. If it's 20 by 20, it increases even more, right? So depending on how you have set up your reward, in this particular case, I'm assuming that I'll give a -1 for jumping to the square first and then give a +5. You'll get 11 point. If you assume that by directly jumping onto the square, you get a +5, then it would be +12, right? It depends on how you have put the rewards. Okay. And the policy is kind of the logic that is being learned by this particular red circle, that, hey, if the circle is in this particular position, in 1,4, right? If it's in this particular position, taking a move right is good, right? Taking a move right is good. If it is in 2,4, that is, where are we? Here, right? Taking a move down is good, right? So these two combinations, it's learned right now. So policy is trying to tell me. And the reinforcement learning is trying to improve this policy. Now the question comes up. We never actually talked about policy in the first place. We have never talked about what is this policy, how is this happening, etc., and etc., right? So let me introduce you to the policy itself. Okay. So do let me know if you are able to kind of see my screen. Okay. Let me draw it here itself. Okay. Now, what we are trying to do, whatever state it is in, let's call this as S1, S2, S3, S4, right? S5, S6. Oh, sorry, this is red, right? S6, S7, right? These are the 7 states that we have gone through this one. Each of these would be, right? This would be some S, A, SB, or something like that, right? All of these are states, right? What we are trying to do is, at any state, let's assume at S1, if it is at S1, now we know taking a right or going to S2 would be a good, good action to take, right? Initially, we don't know, correct? So what we can do is, let's let me put this as in this particular format. Okay. This is something that I prefer to write then and there because of its, ease. S, whether to take action 1, whether to take action 2, or let me do this. Let me erase this, sorry. Okay. Let me put it in this point, exactly. Whether to go left, right, up, down, correct? And what is the cumulative reward till now? Okay, let's call this that. Now let me introduce you to a word, in fact 3 different words in this particular case. This is not the word, this serial number. So 3 different words. You heard value right now, right? There is reward, there is value, and then there is quality. Okay, these are the 3 words that you would be encountering whenever you work with reinforcement learning. Okay, so let me talk to you about these 3 words. What is the difference between these 3? Every time that you take a step, right? Let me put a laser pointer in this particular scenario. I'm not able to do that. Okay. Okay. Every time you take an action, the immediate reward, immediate, a response that you get from the environment, or immediate value that you get from the environment, we have termed it as reward, right? That's something that we all know. What we are interested in is, we are interested in reaching or getting cumulatively the best reward, correct? What is a cumulative reward? We want the maximum of it, correct? Otherwise we could have seen that, this is the shortest path, right? But in this path, the reward would be not maximum. In this particular scenario, the reward is maximum only when we take this path, correct? So what we call the cumulative, reward for any state, right? Let's say if I'm in this state, what might be my cumulative reward if I take a particular, if I'm in this particular state, right? That's known as value, this cumulative reward, value. And there is a function. There would be a function that you have to understand, value function. So value function is basically a mapping of what is the estimated cumulative reward that I can get in a particular state. Okay. If I'm in this particular state, what is the cumulative reward I can, or I have, or I can get, right? The value function is trying to map that. Is that clear to everyone? If not, please stop me at any point of time. Second is quality. Third is quality. Quality is that, right? In here, if you noticed, in value, I am only focusing on states. I have not focused on actions that led to these particular state, correct? In quality, Q, we call it as Q value, right? So Q is basically the quality of the action that you take. For example, what is the reward I can get if I take a particular action, right? For example, if I take a particular action of going right from S1, what is the cumulative reward that I'm expecting, right? That gives me the quality of that particular action. Got it? Is the difference clear to everyone in this case? The 3 differences that are, it's very important that we have a clarity on this, because typically what we work with is Q. In this particular case, we will work with Q. I hope that is clear to everyone. At any point of time, if you have any non-clarity, you can ask questions, right? Great. So what we will be doing is, we will be trying to, in this particular state, or in this particular case, we will be trying to estimate, a function for, estimate the Q values for all the states, right? States and state action pair. So let's say this is S1. Okay, I have to change this to pen, and let me change the color to a little different one, right? So we are at S1. So if I take left, right? If I take an action which is left, my Q, instead of sigma R, let's call it as, there is Q, right? Initially everything is 0, so we are saying that sigma R. When we take a left, it is boundary, right? It can't go left. So we will put a negative value, -10 or -20 or something, right? So that the episode terminates, so that it knows that we can't go left from here, right? But let's assume it is taking a right. Okay, now let me kind of erase this. So another thing that you have noticed is we have to define what is a boundary and what is a reward for the boundary. Okay, right, it is 0. And instead of, okay, let's take right. Okay, when we take a right, we will say 0. We are taking a right, so 1. This is just Boolean. 0 means false, 1 means true. It's just to showcase what was the step or action taken when we were in state 1, and what is the reward that we got. We got -1 total, because we are starting from here, right? So initially our total reward was what? 0. Now once we take one step, it's -1, right? And our Q for taking S1 or going to S2 by taking an action R is something that is -1. Our quality, and this is not at all a quality function, to be very honest, but intuitively this is what we look like.
Akhil, just sorry to cut in between. In terms of time check, can we kind of wrap the first episode of this season, so to say, in another 5 minutes or so, and then continue again in the next second half?
Yes. We are nearing that break. Yes. Great. So I hope this is clear to everyone. Similarly, we will be in this particular scenario. If you notice, we will be having a table of such states and action combination. Rather than what state we took, what was the reward that we got, and what action led to that reward, right? We are creating this table. You got it? So we will have this table for, I believe, in this particular case, all the states and all the actions that we are taking. Correct? Is that clear? There was a question, right? How we will be, identifying what policy would be there. I hope this gives you a clarity on that. Right? Now let's move ahead. With our understanding of this, let's move ahead. Okay. Now the point is, if we have a different initial state, right? Would the same path be of choice? For example, if the red circle started from here, then we can see the same path is not necessarily being taken, right? It's one jump to the right can give us a good reward. Correct? The whole thing is based on where it is starting, the path is the set of states and actions that it can take in order to get the best reward may be different. For example, if I ask you, if my red circle was here, what would be the best path? Can you tell me what would be the best path? If it was here in 2,5. If the red circle was here, intuitively we'll say this is the best path because this is the shortest path. Correct? But the problem is, let's count. It's -1, -2, +10, +8. We get a +8 reward. Correct? If I go from here, -1, -2, -3, -4, -5, +5 is 0, -1, +10. That gives me +9. Right? Even though this is not the shortest path, we are still getting that this is the best path which can lead to best reward. Right? Now, this is just to let you know of two things. One is setting up of reward actually changes the way the system looks at the problem. Right now, the problem is focused on getting the maximum reward, irrespective of whether the path is short or not, because it is getting a better reward out here. Right? If our major focus was on shortest path, then instead of having -1, if I had -2, then the entire system would have behaved a lot different than what we are seeing right now. Correct? So what I'm trying to emphasize is setting up of your reward is very, very critical to ensure that your system is actually learning the right thing to do, right? Otherwise, it is highly possible that you may end up in something which is not according to what you require. Okay. Second thing is, based on where we are starting, irrespective of where we are starting, our policy should be able to navigate us in a direction which would give us the best possible reward. Okay. This is what I wanted to tell you in this particular first portion. So we have qualitatively discussed and came up with the reinforcement learning algorithm, which is based on right now quality values, right? We are trying to identify all the Q values of from any state, right? We are trying to figure out what actions in any state would result in. And based on that, we are trying to derive a policy, correct? And ultimately, after doing everything, because we have only 21 possible states in this particular case, right? We can actually derive a policy very effectively by, which looks something like this in terms of arrows and diagrams, etc. But we have a table behind this, right? We have created a Q table. So to introduce you to that, the Q table is one type of policy that you can actually have in reinforcement learning, right? So you will see the Q table will contain this information that if you're in 3, go right or go up. If you are in 4, you can either go right or you can go down. Or sorry, you can go right. If you are in this particular state, you go left, right? So the whole idea is, now if you notice, this is agnostic of where you start from. No matter where or which state you are in, it will tell you exactly which all directions you can take to ensure that you get the maximum reward, right? Now, this is a policy that we are talking about, but this policy was not something that we were working on the first go. We were in fact working on Q values, obtaining Q values, and based on those, we have derived this policy. Okay, just keep this in mind because this is going to be a very important discussion topic as we move ahead. Okay, now just to wind up, I leave you with 2 questions. What if instead of 5x5 grid world, we had this particular grid world, right? Do you think having a Q table in this particular format would be easy or suitable for us to work with? If you believe yes, it is still feasible for us to work with Q table in this because after all computers are doing this, then think about this. This is a servo, robotic arm manipulator, which have 6 servo motors attached to it, right? Which can move 180 degrees. And it has more than 3 trillion states that it can assume, right? Now again, do you think this would be feasible? In this particular case, would it be feasible to create a Q table, the table that we just created? Right? If not, what do you guess would be a better way to move ahead? Right? I'll leave you with this particular question. We'll come back and we'll focus on this, take it up from here in the next part. And then we'll finally get to our robot, biped robot, and we'll put reinforcement learning there and try to see how we can make it work. Okay. I hope this was interesting, everyone. Do let me know at any point of time if you feel you're not able to follow, or if there is anything that is not clear or anything. Please do let me know. I'll be more than happy to take up those questions. So I think there is a plenary at 10, so we'll take a break now, if it's okay, and then we'll rejoin in the second portion and we'll continue from here. So keep this question in mind and also the solution, and do let me know what you think of this. Okay.
Yeah, thanks, Akhil. Thanks, Pranav. As Akhil mentioned, I guess it's a nice way to keep thinking about this, and it's kind of a good trailer for the next one. So feel free to, if you have any other questions, feel free to just jot it down somewhere, and then we can have more discussions later in the afternoon. In terms of like, once we understand this concept, I can say from personal experience, implementing in MATLAB Simulink is relatively straightforward. It's mostly like whatever we discuss. And since many of you have experience with MATLAB Simulink, putting it there is essentially whatever we discuss, you just put it there in that syntax. So it's important that we understand the concepts. And I think that's what was a good learning from Akhil's discussions. And thanks for everybody for keeping it pretty interactive and having those questions as we went along. Thank you again. Thanks for the organizers, the participants, and Akhil and Pranav. Over to you, Avinash.
Thank you, Dr. Sharat. And thanks, Akhil and Pranav, for the session. So here at this on this note, we'll like to end this session. Thank you. See you in the afternoon.